Today's lesson is about negative exponents. Your learning target says, I can use the rules for negative exponents to evaluate or simplify an expression. We are going to look at negative exponents a couple of different ways. One is patterns, which is this slide, and the other two are sort of a review of other things we've dealt with. So if we look at our table, I have 10 to a power in exponential form on the left, and then we're going to put it into standard form. So just a reminder, 10 to the third power means I have 10 once, times 10 twice, times 10 three times, which equals 1,000. 10 squared means I have 10 once, times 10 twice, that's 100. 10 to the first power is just 110. That's it, 10. Now let's look at patterns. You're going to notice that every time I move down one level, I am dividing by a power of 10. I have one less factor of 10. So if I took 100 and moved down one, I'm getting rid of one of those factors of 10, or in essence dividing by 10. So if I continue to do that, I will get 10 divided by 10, which is 1. 1 divided by 10, which is 0 and 1/10. And 0 and 1/10 divided by 10, which is 0 and 1/100. Now something interesting about this one right here. Anything to the 0 power is 1. I know you don't believe me, so I want you to take a calculator, put any number you want into that calculator, and raise to the power of 0. Try it again with something else. Try it again with something else. Everything to the 0 power is 1. Now, can I just say that 0 and 1/10 can also be written as 1/10? 0 and 1/100 can also be written as 1/100. So I really like patterns, and I am noticing that 10 to the first, right here, 10 to the first was 10. But the minute I put a negative sign on it, the 10 went to the denominator. 10 squared is 100, but the minute I put a negative on it, the 100 went to the denominator. Interesting. All right, let's look at negative exponents from a quotient of powers rule. All right, now on this one, if you remember, I have the same base, I keep it, and I subtract my exponents. So that would be 10 to the negative 2, according to the quotient of powers rule. Same problem, but let's do it differently yet. Let's look at our definition. So that meant that I had 10 once, twice, 3 times, 4 times as my numerator. Divided by could be a fraction bar. And I have 10 once, twice, 3 times, 4 times, 5 times, 6 times on the bottom. So if I cancel, 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 I don't have nothing on top. Excuse me. If I had nothing on top, my fraction would just be 0. I actually have a 1 up there as a placeholder. So it looks like when I did 10 to the 4th divided by 10 to the 6th using my division rule, and I kept my base, subtracted my exponents, I got this. But when I use the definition, I got, oops, that's a 10. Let me erase that, make that a little neater. I got 1 over 10 times 10, which is 1 over 100. Same problem. I did it 2 different ways. Therefore, looking at my pattern, looking at my quotient of powers, looking at my definition, I know that 10 to the 4th divided by 10 to the 6th is 10 to the negative 2, which equals 1 over 100. So the rule is, when you have an base to a negative exponent, you give yourself a placeholder of 1 in the numerator, you scoot your base to the denominator, and you change your exponent to positive. I want you to take a minute, and I want you to write these 4 problems in your notebook before we go ahead and work them out. So pause me for a second, write these down, and then come back when you're ready for discussing them. All right, let's look at this first one. According to my rule, I'm going to have a placeholder 1 on the top. I'm going to move 3 to the bottom, and instead of a negative 4, it's going to be a positive 4. It says to rewrite each of these with no exponent. I still have an exponent there. So if I simply simplify that, and I put in my calculator 3 to the 4th power, or I use Desmos, either one, I will get an answer of 1 over 81. I've now rewritten that. I don't have an exponent. That is my answer. Let's go to the next one. 1 is my placeholder. Move m down and ditch the negative. 1 over m squared, but I can't use an exponent. I could just go m times m to follow the directions. All right, let's try this one. 1 is my placeholder. Move the negative 6. Don't get rid of that negative. Negative 6 goes to the denominator. Instead of negative 3, make it a positive 3. Ditch that negative. I can't have an exponent. So if I put negative 6 raised to the 3rd power into a calculator or into Desmos, I will get 216. A negative 216. Now that negative could go anywhere. It could go outside. It could go on top, or it could stay on the bottom. It doesn't matter where that negative goes as long as you don't forget it. All right, last one. 1 is my placeholder on top. X and Y go to the bottom, both of them. And instead of a negative 7, make it a positive 7 down there. Ditch that negative. If I don't want any exponent, ooh, this is going to be a long one. XY once, XY twice, 3 times, 4 times, 5 times, 6 times. Ooh, my line wasn't quite long enough. 7 times. 1, 2, 3, 4, 5, 6, 7. There is my really long answer. All right, so this slide, we're going to go the other direction. We are going to rewrite each of these with a negative exponent. So I'm not much of a fan on the way that Google writes their fractions horizontally. I really like my fractions to go vertically. And when you are looking at this, it is implied that you have 127 in the bottom. So the very basic way of doing this would be to put 27 back on top, reappear the negative on your exponent. But if you want to be just a little more fancy, 1 over 27 is also 1 over 3 cubed. If you don't believe me, do 3 cubed in your calculator. In this case, move it back up and reapply the negative to your exponent. There's actually 2 answers. Either one would be okay. This first one's pretty basic. The second one's a little more fancy. All right, let's try another one. 1 over 16 is implied that it's 16 to the first power. And so that one, bring the 16 back on top and reapply your negative. That's one answer. But there are 2 more. Can you pause me, come up with the other 2, and come back for checking? All right, for those of you with really good number sense, if I want a 16 on the bottom and I want to use an exponent, I could say that's 4 squared. 4 squared is 16. In that case, I would bring the 4 up and reapply the negative to my exponent. Or 16 could also be found by taking 2 to the 4th power. 2 to the 4th power is 16. So this one would be, bring the 2 back up, reapply your negative to the 4th. It doesn't matter to me if you want to go basic, kind of fancy, or really fancy. Any of those answers are going to work perfectly. All right, last one. This is implied. It's 125 to the 1st power. Oop, my 1 didn't show. There we go. Bring it back up. Reapply your negative. That would be acceptable. There is another answer. Go ahead and pause me and see if you can come up with it. When you're ready for checking, come back. Did you figure out to get 125 on the bottom? You could take 5 cubed. You had that on your perfect cube list. If you did this one in red, you'd bring the 5 back up and you would reapply the negative to your exponent. I don't care if you go basic or you get a little fancy, as long as you rewrote the problem with a negative exponent.